Hello everyone. In this video we're going to be restoring a very rare motor made by Century Electric. As opposed to the usual repulsion start induction run motors that I like to feature, this motor is a split phase design. And what's interesting about it is that it has an internal clutch. As a matter of fact, the data plate is stamped with the word clutch on it. Century referred to these small motors as their Invincible line. This motor is only 1/8 of a horsepower and it sits inside of an S4 frame. As far as their utility motors were concerned, this is the smallest motor that Century ever manufactured. They did manufacture an S3 frame motor, but that was for a fan. This motor has a patent date of 1900 on it, and should definitely be interesting once we tear it apart to see how it's put together inside. As you can see, it has a beautiful skeleton design. It's very open frame, and it's just really a beautiful looking motor. I put the little 6-inch ruler in front of it. You can see it's only about 6 inches wide and about 6 or 7 inches tall, so it's definitely a small one and a delicate one, so we'll have to be careful while we're working on it. So I hope you're going to enjoy following along on this rebuild.
Okay, so I've got the Megger out, and I've went ahead and tested the leads coming out of the motor, and I've showed this Megger before on a couple of my other videos. Basically, it's a hand crank model, so when you turn the crank, it puts out about 500 volts, and it helps you to determine the insulation resistance, just to make sure that there isn't any major breakdown of your insulation or short circuits or anything like that. It's a little bit more of a conclusive test than just the meter itself, so these windings appear to be in good condition. Okay, so what I did here was I used a couple left-handed drill bits to remove the rest of those drive rivets that were in this terminal block. I couldn't get to them from the back side because they were the way that they were driven into the housing. There was nowhere to get to them from the back side. So anyways, we got those out. Okay, so the terminal block was already cracked before we started the project. Now that we got the cover off of it, as you can see, it's broken into two pieces. So what I'm going to do there is I'm going to soak that in some purple power, and hopefully we'll clean it up a little bit, and then I'll try to epoxy it back together using a two-part epoxy. Okay, so when I took the terminal block out, it was actually fractured in more places than I originally thought. So as you can see here, it's in about 3 pieces, and there's also a couple little chunks that are missing from it. So what I'm going to do now is I'm going to go ahead and I'm going to glue that back together, and then once the glue dries, we'll fill in the gaps with some JB weld, and then sand it to the proper shape. And then because of all the cracks in there, I'll coat it with some white epoxy to keep it looking like it did originally. Okay, so here we have the terminal block. First thing I did was glue the main pieces together, and then as you can see here, I took some JB weld and just kind of layered it in the cracks there where the chips were. And once that dries, we'll go ahead and sand that to shape, and then we'll go ahead and paint it. Hopefully it's gonna look like new. Okay, so in order to get the leads out of the housing here, I'm going to carefully heat them with a heat gun because right now they're stiff and brittle, and I don't want to break them if I don't have to remove them. So we're going to heat them with the heat gun, and hopefully that's going to soften up the material a little bit, and then carefully try to persuade them out of there with some needle nose pliers and some tweezers. So we'll see how it goes. Okay, take a guess what we're having for dinner tonight. Is it tomahawk steaks? No, it's even better. We're having Century Motors. Actually, what I've done here is I've taken the motor and I put it in the freezer, and it's going to remain there overnight. The reason why I'm doing that is because I want the stator to get cold, and hopefully it's going to contract just a little bit. And then in the morning, I'm going to take a torch and heat up the outer housing, and hopefully that's going to expand a little bit, and that will create a little bit of clearance to remove the stator from the housing. It can only come out from one side because only one end bell is removable on there. So we'll give it a try and we'll see how it goes. Okay, so now we have the stator completely removed, and you really had to be careful when I was tapping this stator out of here. I really took my time checking it after each couple hits, because this is a real delicate frame right here with this open skeleton design, and it'd be real easy to crack that. And if one of these arms cracked, you know, the motor would have a hard time staying in alignment. So you want to be careful not to break anything. So anyways, we took our time and we tapped that out of there real nice and slowly, and we were able to get it out of there without any damage. So now, as you can see, it's pretty dirty in there. And what we're going to do is we're going to carefully clean those windings, clean the inside of here. We're going to clean it up very carefully, just using a paintbrush primarily to clean up all the heavy stuff. And then if anything, I'll go in there with a little contact cleaner if I need to clean it with something a little bit stronger, but that dries quickly and will not harm the varnish that's on these windings. While I was tapping that out of there, I was being real careful when I was going in with the drift not to hit the windings from the other side. So you really got to be careful when you're doing that, because there's a lot of things that can go wrong when you're trying to get a stator out. So anyways, the next step is going to be to carefully clean this very thoroughly. Then what we're going to have to do is we're going to have to repair the wiring that's the leads coming out of there. And then after that's all said and done, the next step is we're going to have to dry this out very well so that we can put some insulating varnish on there. It has to be warm and dry for that to happen. And now it's a little bit damp because it was in the freezer. So we'll go ahead and start with the cleaning. Okay, so we got the windings nice and clean, as you can see here. Now what I'm starting to do is getting ready to work on these lead wires that are coming out of the stator here. I've gone ahead and I cleaned up these little contacts here, but these wires are all damaged and need to be replaced. In particular, this wire right here has bare wire coming and actually shorting out on the stator here. So what I'm going to need to do is I'm going to need to cut into these bands that are holding the wires in place, and hopefully that'll give me a little bit of clearance to get some heat shrink tubing up there to repair that. And then I'm going to go ahead and resolder on 4 new leads for this, and I'll use some cloth covered wire just like it had originally. So that's going to be the next step. Okay, so as you can see here, we got all the leads replaced, and after I put on the heat shrink tubing, I just covered them up with a little fabric tape just to give them a look like they had originally. And now the next step is some of this fabric insulation on the other side is missing, so I'm going to use the fabric tape, and I need to replace the fabric insulation on the other side, so that's going to be the next step. Okay, so you can see we got the stator wrapped up nice and warm in a heating pad, and that's the way I'm going to warm it up and dry it out. Works like a charm. Just leave it in there overnight and should be good to go. Okay, so what I'm doing now is I just got the bells in a plastic bin, and I'm going to soak them in some purple power for a day or two, and that's how we're going to remove the paint off of them. Also, I checked the bushings on each one of these, and those bushings are in brand new condition. I mean, there's absolutely no play in those whatsoever. So in light of that, we'll just go ahead and leave them in there. So as long as they function like new, just let them be. And they're certainly in great condition. So anyways, we'll pour the purple power in here, and we'll use that to dissolve our paint. Okay, so I'm beginning the process of taking this rotor apart. The first thing I did was I took a bunch of photographs of it, because I have never taken a rotor apart anything like this, and because it has some kind of a clutch mechanism, I don't know how it operates, and I want to make sure that when I put it back together, I put it back together exactly the way that I took it apart. So what I did was I took a Sharpie, and there's a hole drilled in this cover here, and I took the Sharpie and I darkened a black circle inside of there, and then I drew this line just kind of as a reference. The other thing that I did was I took some measurements on how far the distance should be in this gap, and lastly what I did was I took some measurements for the threads that are sticking out here. You can see that there's a collar on here, so we'll have to get some snap ring pliers and take that collar off of there. But I want to make sure that I have the right amount of pressure on it when I put it back together. So I went ahead and took a bunch of photos, and I took some measurements, and now we'll start carefully taking this thing apart, and we'll see what we find. Okay, so what I did here was I put a couple notches in here for each number. I got these numbered in the way that I took them out so that I don't get the parts mixed up. So now I'm going to go ahead and I'm just going to polish up these parts, and I'll bring you guys back once I get the parts polished up. Okay, so I went ahead and I wire wheeled the pieces, cleaned them up a little bit, and now I'm going to go ahead and reassemble the rotor. Okay, so after a little bit of fooling around, we got it back together, and that is the rotor in its completed form. Okay, so we have the pinstriping done, and the two paints that I used to do that was some oil-based enamel from Ace Hardware for the red, and I used this other paint called One Shot for the gold. This One Shot is supposed to be some of the better paint that's out there on the market, but in my experience with doing some pinstriping projects, it doesn't work as well for the pinstriping as the regular oil-based enamel does. But anyways, it came out looking okay. Okay, so I've gone ahead with the Dremel tool and I've ground down each one of the 4 bosses that hold the stator into position. I just took a couple thousandths off of each one of them, so hopefully that's going to help that stator get in there a little bit easier. Putting the motor back together, I don't have the luxury of using the torch on the housing like I did when I was taking it out, so I had to compensate for that by just taking a little bit of material off of those. Also, what I'm going to do is I'm going to mask off the inside of this right now. It's easier to do it while the motor is apart, and we'll put that in there before we do the clear coating. The reason why I want to do the stator first before I put the clear coat on is because I don't want to take a chance on scratching up that clear coat, trying to fiddle around putting the stator in there after the thing has a beautiful finish on it. It's easier to do it now. That way, if there was to be a scratch or anything like that on the surface of the motor, it's easier to repair it before it's clear coated. So we'll see how it goes. Okay, so prior to removing the stator, I marked the center with this red line. So I'll use that line now to reposition the stator as I'm putting it back in so that I get it exactly where it was originally. Okay, so we got everything masked off, and I have it temporarily put back together, and it is ready for some clear coat. Okay, it's a little bit difficult to see in here because it's so small, but I'll just go over the orientation of these parts here. So the first part that goes in here is this insulating strip that goes all the way in the back on the housing itself. The next thing that goes in there is this contact for the centrifugal switch. Then the next thing that is in here is the flat contact for the start windings. Then there's a square shaped insulating washer, then a round one, and then the screw. So it all fits together like a little sandwich. Okay, so for this little motor, I decided to just go ahead and mount it on a wooden base. And I have a piece of walnut here, and I cut the walnut to the proper dimension. Now I'm going to go ahead and use the router and just put a little edge on there, and then we will oil it up with some linseed oil, and then just mount the motor on top of it. Okay, so we got the switch all wired up, and I used a cloth covered cord for it. So it's about time to give this motor a test run.
So now the motor is finished, and overall I have to say I'm really pleased with the way that the motor turned out. It was a fun project to work on. This motor is definitely a little bit more delicate than the other ones, and being a split phase design with that clutch mechanism, you know, it was completely different than the repulsion induction ones like I work on quite frequently. In the beginning of this video, I mentioned that this was the smallest utility motor that Century manufactured, this motor being a 1/8 of a horsepower. But during the restoration, I was doing a little bit of research, and what I discovered was that Century actually manufactured a 1/10 of a horsepower motor, which would actually be a little bit smaller than this one, and they put that in what was called an S4B frame. Anyways, I've never actually seen one of those in person, but at least according to their literature, they did manufacture one. So I misspoke when I said that this was the smallest utility motor that they made. Anyways, it was a fun project, and I really hope that you enjoyed following along on this restoration, and I'll be looking forward to the next project. Thank you very much for watching the video.